All right, guys, let's get started again. So I need to, this one, right? Okay, so the next half, or so the second half of today, as I said, so hopefully everyone or almost everyone is situated now. Okay, we are, as you can see, in a PyTorch environment, and we have installed NumPy, and we have installed PyTorch. So again, we can take a look at our basic script here. Okay, so again, I'm going to run it. So Python basics torch. I know it runs. You could modify it if you want on Nano. That's perfectly fine. Usually I don't do it. I work on my Mac usually, right? So I just use the editor there in my Mac, Xcode, but you can use the text editor here, should be fine. So let's go ahead, and that's what I'm going to do, right? So I'm going to switch over to the folder, okay? And I want to, so since I had it open here, I'm going to save it, but then close it, okay? And now I'm going to go ahead. Make sure you're always aware of not having too many versions of a file. Okay, so here, if you notice, I only have the terminal here, and then I have the folder, right? So I'm going to right click on this, open with text editor, and now I'm going to proceed and make changes to this file. So let's add a couple of libraries again. So let's do import torch, import numpy as np. Most of your programs will have a lot of libraries, okay? You know, and let's just stop there for a second. So now, what do we want to do? Let's start thinking about the main data structure, if you will, in deep learning and PyTorch, which is called the tensor. All right, so let's look at what is a tensor. So really, a tensor, as I said before, it's an array, a type of an array, right? So it could be a 1-by-1 array, which is called a scalar. It could be a 1-by-n array, which is a vector. It could be an n-by-m, which is a matrix, or it could be an m-by-n-by-m-by-h, which is 3 dimensions, or it could be n-by-m-by-h by ... however many, right? And that's what those are called tensors. And although it's probably the thing that's the most confusing of all of deep learning, it's also one of the most powerful things, because it's really what allows you to do things in parallel, etc. Okay, so it's very important that we spend a lot of time thinking about it. Okay, so the way that we're going to do this is that Python has lists, okay, but NumPy and Torch have matrices and vectors. Okay, so let's go ahead and create one here. So I'm going to say a, this is a variable in Python, and I'm going to call torch. So torch dot, and you can see torch is an object-oriented thing, a library. Basically, we're going to be seeing every line of code that I'm going to write is a new thing. Okay, it's a new thing. But this one is, so we're going to really just learn by practice. Okay, it's really the best way to do it. All right, so we're going to practice creating a tensor, and notice I'm creating a tensor of dimension 3. What this means, usually when I say ones, is that the contents of the tensors is all ones. Okay, and then what you put in the parentheses is usually the dimensions of it. This is the thing that will hold all of our data. Okay, all of our data, which could be very, very big. This could be very huge. Okay, is what's going to store our information. So let's go ahead, and the first thing we want to do usually is print it. So I'm going to go ahead and just print that variable a. all right, and see what it is. Okay, so I'm going to see what it is. So I'm going to save this file. I saved it. Now I'm going to go into the terminal. I'm just going to do cat basics just to confirm. You can see it's got the code that I just wrote in there, so you can then just clear it. ls, and now I'm going to run it. So Python basics torch.py. Do you see that, guys? So how do you interpret the data here? What is that? They're floats. Very good. So that's one of the main things that we have to worry about, the data type, right? By default, we didn't specify it, and it's floats, but we could have specified it. And I'll show you guys later. What else do you see there? It's okay. It's again, I'll repeat it. Python, you got arrays and lists, which are lists. In NumPy and Torch, you don't have arrays. You have matrices and vectors. Yes, they're like arrays, but different. Much more efficient for process. Does that make sense? Very important. It's so important that TensorFlow has the word tensor in the name itself. All right. So just think about that, right? So Google's TensorFlow literally has that word in the name because it's a flow of tensors. PyTorch is also a flow of tensors, but it's called Torch or PyTorch. Got it? Yeah. So it's all ones there. So it's not an array. To answer your question, it is a tensor. You can see the word. It's called tensor. What about the contents of it? What can you tell me? All ones. Why all ones? Because we wanted a tensor of all ones. We said tensor.ones. You're probably thinking, oh, is there a tensor.zeros? Yes, there is. Okay. What else? What else is important there? Something that's critical. No way. The size of it. We've got how many values? 3. The dimensions, right? We have 3 dimensions. So if we go back to the script, you can see that I created 3. Make sense? Very important. Notice over here, I can do like that, right? So if I do this one, A1, I'm going to change this to 6, save it. Now I go to the terminal. See that? Now I have 6 values. Okay, this is important, as you will see, because this is what we're going to be manipulating in our data. Today, we're not even reading data. Okay, we're not even getting to the point where you have to read any data. Instead, what we're doing is we are just playing with these tensors, trying to become familiarized with them, all right? Because they will be the point of confusion in a lot of what we do. So let's go ahead, and so let's play. Oh yeah, go ahead. Yes, it's a vector, right? That's what you're saying. It's almost currently it's not a vector of 1 by 6. Currently, it's just a vector of 6. There's a slight difference, but technically, yes, it's a vector of 1 by 6. You can think of it, or just 6 in a line. We just haven't defined if it's horizontal or vertical. That's really important, as I said, although, because all of this comes from a field of mathematics called linear algebra. And in linear algebra, you have a set of rules of how to deal with math operations of multiplications of matrices and vectors. And so those things matter then. But we only need that for our operations. So as we face the challenges, we'll address it. Okay. But good, we're going to get to shape. This is one of the amazing or really great things about PyTorch. PyTorch, since the beginning, has been very accessible. We can look at the shapes, we can look at the data. Believe it or not, it was really difficult to get this before with TensorFlow 1. They've changed that now with TensorFlow 2, but this is one of the things that makes PyTorch preferred by people. It's just ease of use. it integrates seamlessly with NumPy, which is basically the language of data science. And so it's really great. All right, so we're going to just continue playing with it to become familiar with what we can do. So now what we probably want to do, I'm going to switch this back to just A. And what I want to do probably is I just want to change a value, right? So I'm going to change a value. So I'm going to say A. And notice this very much like with lists, right? So you're just going to say, we got 3. So it's 0, 1, 2. So index 2. You see that? And now I want to change this value, and I'm going to change it to 17.0, for instance. Right? Just playing with it a little bit. And so now I'm going to go ahead and print A once again. I have my strange things that I do, so you guys don't have to do things, but I like separating things out like this. So basically, I'm going to print this one out. I also want to print one of the values. So I'm going to do print, and I'm going to say I want to print A1 for whatever reason. I just want to take a look at it. But also, you know what? I want to maybe make sure it's a float. So I'm going to typecast it to float. And just pay close attention to the parentheses, which is just standard programming. Make sense? All right. So let's go ahead. Hopefully there are no errors. So let's go ahead and run this one again. And there you can see I have now changed the value to 17 here, right? You can see that there. And I printed out the contents, I think, of 1, 0, 1, right? So this one. I printed out that value. Everyone with me so far? Pretty easy, right? Okay. So if you have any issues or questions, just raise your hand, okay? All right, so let's do something a little bit more complex now. Let's go back to the code here. And let's say that I want to, this is Python originally, right? So it's Python 3.6. So it might be, I might have a situation where I have a list, right? So I have a list. Let's say it's a list of floats of 4.0, 1.0, 5.0, 3.0, 2.0, 1.0, right? So I have 6 values in there. But this is a Python list, okay? So make a note of that because this is really important. This will not work in PyTorch, right? For deep learning operations, multiplication. So this is just a Python list, okay? But now what I want to do is I want to convert it to a tensor, all right? Because I want to, so I have some data, I want to convert it into a tensor, and then I can apply all the power. So what do? I'm going to call it B underscore T for tensor, right? That's kind of a practice that people follow. And I call torch, and I say that I want it to become a tensor. Okay, and of course I plug in B. Do you guys see this? So now I've converted this into a tensor, which means I'll be able to process that data with PyTorch itself. So now I want to print it out. So I'm going to do B underscore T. You see that? I can also print out B itself like that. All right, so I'm going to go ahead, save this one. All right, so I'm going to go ahead, I'm saving it. Now I'm going to go back to the terminal. I'm going to hit clear here. There you go. What do you guys notice? What's the difference when you print them? This one's just a standard list in Python. This is a tensor. It's actually a tensor now, and so we can use it. Okay? Pretty easy. Okay, so let's go back to the script. All right, what else can we do? What about, so all of these have been one-dimensional, right? One-dimensional. Now let's start with a list in Python. Now, what are two-dimensional arrays in Python? A matrix would be, well, yeah, in Torch, but in Python, a two-dimensional array is basically a list of lists, right? That's kind of the definition of it, list of lists, right? And so I'm going to make a list of lists, right? So let's say I have 4.0, comma, 1.0, comma, then I'm going to have another list here of 5.0, comma, 3.0, all right, comma, and then I have 2.0, comma, 1.0. You guys see that? That's my list of lists. This is just Python, but I want this to be a matrix, as somebody said, a matrix, right? In the sense of Torch. So then what do? I'm going to grab C Tensor. And once again, I call the power of the Torch library. So torch.tensor, right? And then I just plug in the letter C. So once again, I can do print C and also print CT. Oops. Like that. Make sense? So now let's go ahead and run this one. So I'm going to save it. I'm going to go to the terminal here. I'm going to hit clear. And there you can see. Here, this one is just a list in the Python sense. This one is a matrix in the tensor sense. Okay, very important. Now the dimensions of it are what? What's the shape of this one? The tensor. Huh? 3 by 2, right? 3 by 2. That becomes extremely important going forward. Okay, guys? These dimensions are extremely important for us to understand. Usually, the rows will be what? The samples. You know, whatever it is, right? The unit, and then the columns will be what? The features. But we'll see that, you know. Right now, we're just kind of playing with this, just that we can get a feel for this, because there's really no other way, right? You really have to do that and kind of get a like a mechanical sense of how it works. Muscle memory, if you will. Yeah, go ahead. Say it again. Yeah, everything is 0. Starts from indices, right? Yeah, starts at 0. Yes, everything. Everything. Okay, we'll see that in a second. So, what else do we want to do? Now, a very powerful tool or way of doing things is to always look at the shapes. Okay, the shapes are really critical, and you'll see how critical they are. In fact, a lot of the complication is always about. I'm recording this, so I'll post it on video. All right, that's okay. I'm just saying. All right, so what else do you want to do? Maybe we want to take a look at the shape, right? And Torch makes it super easy. I mean, all of this is very simple. So then, oops, sorry. So then we're going to do here CT. You know, this variable C underscore T is already a tensor in Torch. So it's an object. It's got things like shape. Okay, it's got, you know, functions or you know, methods associated with it. So let's go ahead and save this one. And now let's run it. So I'm going to do here, clear, run it again. What do you see? Torch size 3 by 2. You see that? This is always very important to do. In fact, some of the time you won't even look at the data really. But you will because there's so much, right? There's going to be so much data that you can't really even look at with the contents of it. But these shapes are going to be fundamental to what we do. You know, deep learning is literally this, getting all these shapes correctly done, okay? Aligning the vectors, the matrices, and so on. All right, great. So we're moving really well. I'm not hearing that many questions. So now let's go ahead. If you notice, I'm putting in different separations here, just kind of separate the different ideas. Okay, so now I'm going to say, let me just do this. All right, so now I'm going to go over here. Oops. All right, what else would we want to do? So let's create we did a ones tensor, right? Let's create a zeros tensor. All right, so I'm going to go ahead here and create d underscore t. This is going to be directly just a tensor. This is very handy whenever you're trying things out. That's why zeros and ones are very handy. You just create a tensor really quickly and, you know, do something with it. At least make sure you align your architecture correctly. So I'm going to do here torch dot zeros. Okay, and notice that I'm going to specify the shape 3, 2. So this time is going to be a 3 by 2. So now if I want to take a look at it, I can just print it. So I'm going to print d underscore t. Okay, I'm going to save it. And I'm going to hit clear here. And you can see I've created an all zeros tensor that is 3 by 2. So the contents of it is all zeros. Okay. All right, so let's go ahead now and just keep going. So let's say that we're going to do several things here. The first one is we want to modify just one of the values. All right, so how do I do that? So this one should be pretty straightforward, right? You guys are familiar with this, right? I want to change the first row, second column, right? So I'm going to do then 0, 1. This is pretty intuitive. We've all done it before. Change it to 17.0. Additionally, then I want to print out a value, let's say. So I'm going to, so let's say I'm going to print what do I want to print? I want to print the row where I put this. How do I do it? So it's obviously dt, right? And then what would you guys suggest? So it's obviously something that goes here. To print, I want to print out the entire row. What do you guys think? What do you put here? For the first row. 1, 2, but that only gives me for the second row the last element, right? They start at 0 first of all. I want the entire row. This by the way is called slicing. All right, slicing is this. Okay, yeah, that's a good idea, right? What he's saying. So he already knows a little bit about slicing, or we can just do 0. 0 will grab the first row, right? So that's it. But he's right, and I'll show you guys in a second kind of what he's talking about. So let's go ahead and try it out. So I'm going to save it. Clear here. What do you guys see? Did it work? Yes, right? Because it gave us, I changed the value to 17, and then I got the first row. Now, what he was talking is using the colon symbol to kind of slice ranges, right? So let's try something with that. This, you know, you guys will do many of these throughout the semester. This is a fundamental principle. But let's say I'm going to slice out something interesting out of this. All right, so we have to think, let's say, more complex rows and columns, right? So then that's separated by a comma. That's still the same thing. What changes is really what goes here and what goes here, right? To specify those parameters. So let's say that I want all the columns. I want all the columns, but I only want certain rows. Okay, how many rows do I have? I have 3. So I go 0, 1, and 2. But I only want, let's say, from 1 to the end. Okay, so think about how this works. You're not, you just say I want from 1 to the end, but all columns. Or you could just say I just want the last 3 columns, or sorry, the last 3 rows and all columns. Or you could just say I just want the first 2 columns. You can think about, in terms like that, right? And so you got to figure out how to do this slicing. So let's say I want all columns. That's simple. As he said, colon. So what this means is here you specify the beginning, here you specify the end of those columns. So if I want it excluding the let's say I want from the second column to the end, I would do it like that. But given that I want all columns, I say nothing here, which means from beginning, nothing here, which means to the end, right? So from beginning to end. So I get all columns. But here, I want to slice a little bit more, in a more limited way. So I want to skip. I don't want the 0 row, right? I just want from 1 to the end. Then what do? I say 1, colon, and nothing here. If you say nothing here, then it just goes to the end. That's the beauty of it. It makes it simple. Because right now, it's 0, 1, and 2, but you may not always remember. And so it makes it a little bit more useful in your code. Does that make sense, guys? Making sense? All right, imagine an algorithm that somehow took different data sets of different sizes. Well, you don't have to worry about the last one. Questions? Pretty easy, right? No questions. All right, so let's go ahead now and print this one. So I'm going to hit save. Hit save. Okay. There you go. So this was the original one, right? But I only started and grabbed these 2, right? I grabbed these 2. So therefore, it gave me that tensor. Make sense? All right. Great. So this is, don't forget, this is called slicing. What I've shown you this is just the tip of the iceberg, right? There's a lot more there, and we'll just do examples as we need them going forward. So let's go ahead then, go back to the code. Let's add a new separation here. Okay, so what else can we do? Now, let's do the following. This is something I don't expect you to fully understand it now. It's a bit complex to understand in the beginning, or why you would even have to do this, but it is important later. Okay, when you do very complex matrix multiplication, sometimes you need to add dimension, an additional dimension, right? So let's take a look at this example, for instance. So I'm going to do, and this, by the way, is called Unsqueeze, okay, or squeeze. Okay, that's the name. That's the name in NumPy. That's the name in TensorFlow. That's the name in PyTorch. What you have to remember about this is that it adds dimensions, okay? And right now, as I said, it may not seem so obvious. Later on, it'll become a little bit more obvious. But let's just take a look at what it is. So I'm going to actually label it, and I'm going to say unsqueeze, and that's the terminology, and maybe add a little bit, adds, for instance, a dimension of size, let's say 1 here. Okay, so let's start with dt, but we're going to create a new one. Okay, and I'm actually not even going to use the unsqueeze function. I'm just going to use it another way, right? And then we're going to see the unsqueeze. So I take this, right, the original dt here, right? Now I can also do print, because this just gets into my own sanity checks, right? I'm always checking. Am I doing, what does this look like? And so I'm going to do DT shape. I want to see what the shape of it is or print it out. Now I go in here and I'm going to do some slicing magic. All right, so what I'm going to do is I want to add a dimension at the end. Okay, so I'm going to say none. I need to use uppercase, none. And I'm going to also add in here 3 dots. What these 3 dots say is basically, look at the dimensions that it already has, right? Keep those, but then add a 3rd dimension. Because this, what's beneficial about this is whether you have several dimensions, you can have 1 dimension, 2 dimensions, 3 dimensions, it'll just keep them. It'll keep them like that, and it'll just add this additional dimension, okay? So again, this is one of the tougher things to understand, but let's try it out. So this is related to Unsqueeze. So now what I'm going to do here is I'm going to print it out. So I'm going to print DT1. DT1. Oops. Do you see that? And I also want to print out the shape. It's always very useful to get into the habit of just understanding the shape. So it's going to be the shape for DT1 like that. Dot shape, because it's a tensor, it's got the built-in shape method. Okay, with me? All right. So now let's save it and let's run it. Do clear. Do you see that? Do you see what happened here? So here I printed out the new tensor DT1. Okay. It's kind of hard to see, right? It's a little bit hard to see. It's better to visualize it here in the shape. Originally, it was a 3 by 2, right? Now it is a 3 by 2 by 1. I just created a new dimension, okay? And this, again, is just an example of the things that you can do. So you had this question, for instance, of 6 versus 1 by 6. Remember that? So if we have just an initial tensor, it's just of size 6. But if we did something like Unsqueeze, we can make it 1 by 6. Still technically the same vector of 6, but now that 1 by 6 is better defined for us to do operations. Okay? Does that make sense? Yeah. Okay. So it looked, you can look at it here, right? So it should be 3. It's a volume. It's a volume, and so it's 3 by 2 by 1. So it would be, let's see. So let's grab this. We'll have to grab this. Let me just do this. Copy, and we can put it here, I guess. All right, so there it is, right? So it's 3 by 2. So we got to look at these. So there are 3 here, right? 3 here. Then each row, because it's this one to this one and a comma. Do you see that? And then there's this one to this one and a comma. And then there's, this one to this one. And so we can basically, and these are the outside brackets, square brackets, right? So then we have 3. Then each one has 2. So it'll be these. like that. And then I think each one of these is a 1, I think. So let me try this. Let me go back to the code. Let's see it. Without this. So let's print DT1 before. D underscore T underscore 1. Do you see that? So this is the one before, should be DT, right? Yeah. So DT, right? So this is the original one, and this is the one with the new dimension. So we can also, and we have the shape here. We do the change, and then we print it out again. Make sense? So let's see what this looks like. So I'm going to hit save, hit clear here. All right. So see, this one is the 3x2, and then this is the 3x2x1. Trying to think how to interpret this visually. It's a volume, right? So it's 3x2x1. How would that be represented? So the first one is 3x2. And this one is, I would say by 1. It's like it's got to have a, you see that? So it's 3x2x1. It's a volume, and so it's a little bit confusing, to kind of interpret, but it's definitely got that additional shape. That's what you have to get out of it, right? And that's what Unsqueeze does. Okay. So if I do another one, for instance, let's think about changing this a little. I'm going to do D underscore T2 equal DT, but this time none, comma, oops, none, comma, dot, 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 square bracket, right? You see what I did? Now, I'm going to try this over here. This is what DT2 shape. Let's try that one. See the dimension? It is now a 1x3x2. I just added the dimension in front of it. Do you see that? And again, it looks, if you look at it, it kind of looks like the original one, but it's not. Notice here that the original one had what? 2 square brackets here, right? This one has what? 3. So it added that additional dimension, okay? So it's almost like saying, what is something that is 1x3x2? Okay, so, it's a different sense of it, right? So it's maybe like 1 up, right? Maybe like going up because it's 1x3x2. So that's what gets a little bit, tricky with these. But it's always better just to think of it in. The only reason why you need this is when you need an operation, a math operation in the sense of linear algebra, you need to make sure that so here's the thing. So for instance, you need to multiply 2 vectors, right? Well, to perform the operation, it needs to be like that. This is the correct one, that's the incorrect, right? That's the context where this goes, okay? That's the only reason why we kind of have it, is because when we're going to do an operation, we're going to need to sort of flip it in some way. Not like this one, this won't work, this will work. All right, and when we're doing this, you know, it means we have a lot of data there, right? Another way of viewing this is, yeah, so when we do images, for instance, right? So we have an image, you know, that's, you know, we have 100 images and they're 28 by 28. So, but anyway, so that's the intuition with this. And for now, just think of this as manipulating these vectors and matrices, right? So that's all you have to worry about for now. As I said, this is a complicated thing that we will come back to as well. All right, so let's move on to another one here. Let's do another tensor. This time it's going to be a random tensor. Okay, so let's go back to our, let's clear the screen here. So I'm going to go here. And I'm going to create a new tensor. This one is going to be batch. Let's call it batch T. Okay. And it's going to be, notice, for instance, this is going to get a little bit more complex. So I'm going to do equal torch dot. I'm going to create a tensor. This time it's not a ones or zeros. It's going to be a rand n. What do you think that stands for? Some kind of random, right? Random. All right, and then notice that I'm going to specify some dimensions for this one. So the dimensions for this one are going to be 2, 3, 5, 5. What kind of a tensor is this one? A 4D. Exactly. Very good. 4D. Again, you know, how do we interpret this? Well, I'll give you an example here. This one might be a little bit better to start understanding it. Imagine this is the shape, right? So what do these stand for? These stand for the batch. Not always, but not always. This is just you right now decided that this is, or PyTorch has certain conventions, but all of this is very flexible. Then you have channels for RGB. Then you have rows. Oops. Then you have rows. Then you have columns. So how do you interpret this now? You've created a tensor, and what do you think this, based on this, what do you think this tensor is for? Right, so actually two in the batch. Not 2 batches, but 2 in the batch, right? Of what? Of what did you say? Images, right? Images. What's the size of the images? 5 by 5, right? But what is that RGB? The channels. Why? Color images have actually, instead of a grid of 1 grid of 5 by 5, it would actually be 3 grids, right? Of 5 by 5. 1 for the red, 1 for the green, 1 for the blue. Does that make sense? So do you see how now it's a little bit slightly better to understand, right? You understand that you, in your mind, you can understand that you have this data. I have, you know, this will store this batch, and that's why it's called a batch, can store 2 images. Where each image is 3 by 5 by 5. That is to say, you grab an image, it's got the 3 channels, and the dimensions are 5 by 5. So if you build that tensor, you can load 2 images on it. You see that? That's a better way of visualizing this, because you just have to think, okay, this is the size that I want, and then just put it in that size. Yeah, go ahead. What does the image look like? You're saying it's not like this, right? So what so you're saying a larger image? Is that what you're saying, or what? If it's a 28 by 28 image, is that what you mean? Instead of a 5 by 5, then change it from 5 to 28 by 28. If you only have, let's say it's not a color image, right? It's a black and white image. Then instead of a 3, have a 1 in there. And let's say you have 100 images instead of 2, then put a 100 instead of a 2. You see, that's the whole point of it. Uh-huh. Yes. Yes. Categorize. What do you mean by categorize? This is just about loading the image. Imagine you have a folder with a whole bunch of images. All we're doing right now is we created a tensor that can hold the data. That's it. We're not going to do anything beyond that right now. Does that answer your question? Okay, yeah. So this is just, again, the name kind of implies batch tensor. It just means that it's a tensor. If you call it a batch, is basically that you load. You can't, let's say that you have 1 million images, right? Not even PyTorch or TensorFlow can receive 1 million images at once. Okay, you're going to run out of memory. It just doesn't work. So you have to load the data. When you load data in parallel in batches, usually batches of like 64 or 100 batches. In a for loop, it's like, imagine you grab a shovel, right? And then another one, kind of like that. So you load 64 images, then another 64, then another 64, then another 64. And that's usually referred to as a batch. PyTorch actually needs that order: channel first, then rows, then columns. It's more strict. PyTorch is less strict, but it's good. It's a good thing. It helps you actually to make sure that you always have things in the right dimensions. Does this make sense? All right. So today we're not looking at loading images or anything like that. As I said, today the key objective is just to get a feel, start playing around a little bit with these tensors. Obviously, I expect you guys, when you go home, to repeat all of this multiple times, right? So that you practice. All right, any other good questions? Any other questions? All right, so I've created this. So now let's go ahead and print the batch. As you will see, it's a big batch, right? So it starts to become impractical to start printing things at some point, but I'll print it. So I'm going to call it batch underscore T. And I'm going to do also print batch. What is it? Shape, right? Shape. So shape is your best friend. Okay, very important. I can't stress enough how the dimensions are the thing that's going to trip you up in a lot of these things. All right, so I'm going to save the file and go ahead, run it. See? Pretty, right? All right, so now it's a little bit more. Oh, wait a minute. I have an error. What's my error? Oh, yeah. Batch T, right? All right, so save it again. Here. You can see how this is, very small and it's already pretty big. But there's a nice interpretation here, right? If you look, there's one. You see that? That's one of the first dimension, and that's the other one, right? So the 2 is this one. That's one. And this is the other one. Then what else do we have in the interpretation? The channels, right? Hey, give me a sec. R, E, B. You see that, guys? And then within each one, 5 by 5. Did that make sense? You see this one's a little bit more of an better interpretation. Is it not 5 by 5? Did you have a question? That's, well, it's random values. So it's actually, remember, I just did random and I'm playing with the shapes. But if we had real images, it would be what? 0 to 255, something like that. Right? And then we need to normalize it because we don't want 0 to 255. We would want values within the range of -1 plus 1. We'll learn that later on. Does this make, right now it's the scale is what matters. This is the thing. Your mind just has to change. Okay, when it comes to deep learning or machine learning, your mind just has to think like this. Okay, that's why this is fundamental. Okay, all right. So again, I'll repeat because this is more interpretable for us, right? I don't know if you can see it. This is the first element in the batch. This is the second element in the batch. Right, that's the, if I go to the code, that just means that's the 2. Okay, then now the 3, what is that 3? Okay, I just grab the first one, right? So I'm going to grab this one, that 3, notice there's 3 here. Those are the R channel, the G channel, the B channel, red, green, and blue. And then each one, if you notice, just the inner part of it is 5 by 5, the grid. But 5 by 5 really so that we can visualize it. No image will be 5 by 5, it'll be 28 by 28. That point is not so interpretable anymore. And so what becomes handy is things like that. You can see that this object is 2 by 3 by 5 by 5. All right. All right, so let's keep going. All right, so now later on, there's a concept called, just make a note of it or something. There's a concept called broadcasting. Broadcasting is a technique for multiplications in NumPy and Torch. We're not going to see that right now, but just be aware that that's a topic that if you want to explore on your own, you can, okay? Again, it's just about matrix operations. We're not going to do that today, but I'm just kind of introducing the idea. All right, so far you've seen me that I just use the default data type. However, data types are important in PyTorch, right? Usually we want to use floats, but we can use integers and other kinds of things, Boolean and so on. So let's take a look at that just quickly. That's important actually. Sometimes you'll have problems with data types. All right, so you have to. So actually, I would recommend that you always put in the data type. Okay, explicitly. That's an important one. So let's go ahead and do that. So I'm going to create a new one here. And, I'm going to add a little title. I'm just going to say here, data type for a tensor. All right, so let's say we want points, right? So we're going to say double points, kind of float. So we're going to do torch dot ones. Right, so I'm going to do all ones. So what do I need to specify? So one of the things about TensorFlow and PyTorch is that they are libraries that are called verbose. And what that means is that you put in a lot of words whenever you're defining anything, right? And that's just going to become very common thing. So, it's 10, right? So double points basically means what? We have 10 points. And then how many values? Well, the X and the Y, for instance. So then 10 by 2. And then after that, we can always specify the data type just by saying D type. Okay. And then now we're going to say torch dot double. Make sense, guys? All right. So create the data type for this one. Let's create another one. I'm going to say short points, and there are other data types. This is just kind of to introduce it. So it's going to be torch dot. Now notice in this one, I can do a different approach. I can do tensor. And then instead of just specifying the dimensions, I actually can provide the data. That's a list basically, like I would in Python. So it's like this, right? So it's this is going to be a 2 by 2, right? 2 by 2. So I'm going to say 1, 2, and then this is going to be 3, 4. Got it? All right. So now let's specify that's the tensor that we're providing this, but it's sorry, that's the array list that we're providing in Python that will be converted to a tensor. Then I'm going to do d type equal torch dot short, right? So this is short. Got it? All right. So I created the two tensors of that data type, and now I want to print them out and take a look at the values. So I can do a. Oh, sorry. What is the? So it's short points, right? Short points. Sorry. So double points and so I'm going to do double points. Okay, so let's try that one. So I'm going to save it. Okay. And there it is. You see that? It's nothing more than a float. What's important though is that how it was created in memory, what? It chooses a certain number of bytes, right? You know, it might be 32 versus 16 bytes or 8 bytes and 16. So it is significant in that sense. But as far as we look at it, it'll look like a float. Okay. All right. So, and you can see here, float 64. Do you see that? So we could also have used, so basically this is sort of saying that double is float 64, okay? Which you can use directly. And I actually prefer those things more explicitly. I can try the other one. So I'm going to go, and what was the other one? Short points. Short points, right? So I'm going to save it. I'm going to clear here. What do you see here for this one? In 16, right? As I said, I kind of prefer these a little bit more to that, but this is an example of all the options. All right. You can also print out the data type word itself. So we can say, for instance, here, let's use short points. But let's say short points dot d type. And what this gives us is the data type for that specific tensor for whatever reason. You want to remind yourself of what it is. So then you save it. And there it is. The torch in 16, the same thing we had gotten. Make sense? Everyone with me so far? All right. So now that we're ready with this, now let's take a look at a little bit more. All right, so let's play with this a little bit. So a tensor is a thing, right? And manipulating tensors is essential. That's, one of the main things that you do is just manipulating tensors this way and that. So let's take a look at a tool that will allow us to manipulate tensors. Okay, so let's create a tensor torch dot ones. All right, and we're gonna make it of dimension 3 by 2. All right, so there is in Torch a function called the transpose. Transpose. And what the transpose does is it can switch things around, move them, and there, so we're, let's play around with it a little bit. All right, so I'm going to create a new variable a underscore t for tensor, right? T. And then now I'm going to take the original a, right? And I'm going to try to move things around, right? So for instance, let's just see. So here we kind of move things around by dimension. So something like 0, 1 versus 1, 0. Do you guys see that? Make the 0 dimension the 1 dimension, make the 1 dimension the 0 dimension, okay? And a lot of these things, you kind of have to practice with them a little bit, but let's try 0, 1 first. Let's try 0, 1, right? Obviously, we need to print this. So let's do print. And what are we going to print? I'm going to print a dot shape, for instance. But also, I'm going to print the transpose version of A. Okay, so I'm going to do A underscore T shape. You see that? So both of them. And so let's try this out. So I'm going to do save. Clear here. Right, and you see here that it changed, right? So it changed from 3 by 2 to 2 by 3. You guys see that? All right. So that's the general idea with this, with the transpose. Again, we're not really using this right now, but it just kind of gives us a sense of how these things work. Another way of doing this is directly using the method of the tensor itself. So for instance, I can say AT, I already have, and instead of using torch.transpose, I'm just going to say a.transpose. A.transpose. Do you guys see that? So it's kind of the same thing, but directly just using, oh, this should be equal, directly just using the built-in method of the tensor itself. Okay, so I did a torch 1, 3, 2, that's still the same. And then AT, that's A transpose. And now here, I can try things like 1, 0, for instance. We're going to print this out. Print a dot shape. Print AT dot shape. Okay. So let's once again just visualize this. Right, and you can see here, it's actually hard to interpret. Comment this out so I'm not confused. All right, so now I'm going to print out the original image, which is 3 by 2, right? And then the transpose version of it, 8. Okay, so I'm going to go ahead, save it. All right, and you can see, it kind of inverts from a 3 by 2 to a 2 by 3. Yeah, go ahead. What? Well, just try it. I mean, that's the thing that what I would recommend. So let's say then AT 1, right? And then you just do A dot transpose, correct? Yeah. And then here, what is it? 0, 1, right? It's the dimension, right? So we just want to take a look at what this is. So then we take a look at the shape here. It's going to be AT 61. All right, save it. So in that sense, in that case, let's see. 3.2 is the original, correct? 3.2 is the original, this one. 3 by 2. And then AT is 1 by 0. So here it is 2 by 3, right? Okay. So 2 by 3. It flipped them, correct? And then if we look at AT1 is 0 by 1, which basically means 3 by 2, 2 by 3. And this one is 2 by 3. Let me think. 3 by 2. Does this one also, what did this one end up being? 2 by 3? All right, so yeah, go ahead. Let me look at the definition. So this one is torch transpose. So torch transpose. Dimension 0 and dimension 1. The first dimension to be transposed, the second dimension to be transposed. Oh, okay. So then this means which dimension? Let's see. Returns a tensor that is transposed. The given dimensions are swapped. Resulting out here. Storage. It's 3 by 2. So let me try this 0, 1. So the original is 3 by 2. First dimension to transpose. Yeah, so it shifts it. All right, let's do this exercise here. Instead of ones, I'm going to do rand random. Okay, and instead of shape, actually, I'm just going to look at the data itself. All right, so we got random 3 by 2, right? And then I'm going to get rid of these to simplify it so that we can get a feel for it. So let's leave it at 0, 1, AT, and now we're going to print both of these out, and let's just take a look at what the data looks like. All right. So I'm going to hit clear. All right, so we've got, guys, so we have here column 0559, 197, 233, and then this column 13303. So it took this and made it into that, and then it took this and made it into that, which is the standard definition of a transpose, right? So now let's try the other one, and see what it does to it. Let's go over here. 1, 0, right? So it took 948 and 97, put them like this, 3, 1. So it did the exact same thing, correct, as before, with the 0 and the 1. So I'm trying to, so it does the same thing. So what's the, so it just swaps the 2 dimensions, right? 0 to 1. Yeah. One, two. So after this, you want to revert it back. All right, so let's try that. So that would mean taking AT1, and then AT dot transpose, and then 0, 1. So then this will be AT1, or sorry, not just AT1, right? Like this? Is this what you mean? All right, so we want to revert this one back. Let's try that. And reverted back, correct? So it reverted back. So I'm trying to think what I'm not right now clear is I'm looking for a definition of transpose, because it's of what it is that it's 0, 1, 1, 0. What it's just what is being, I think maybe it might be that when you have 3, the 3 might be the positions, but you just specify by the index what you put there. Do you know what I mean? I think that's what it is. Which, usually you just check, you just double check that it did the thing that you wanted, but because we put 0 and 1, or we put 1 and 0, it's always kind of flipping it, correct? So is it that, let me try something additional. Let me see if this works. So for instance, let's say that I'm gonna do, what if I do this? Do you know what I mean? Okay, so let me try that. I don't know. Let's see what happens. So in that case, what did it do? It didn't take it, right? Didn't like it. 2-1. All right, it didn't like that. Zero, zero. I think it just doesn't like it. Huh? What? Yeah, so that's not what it was. All right, so if we try this. Yeah, this takes it. So transpose returns a transfers as that is the transpose version of the input. All right, let me try a higher dimensional tensor here. Let's try the following. Maybe this will become a little bit better. All right, so let's do some tensor, and we'll end with this for today. So torch dot random, correct? Rand n, and this one, let's say 3 by 4 by 5, right? So this is a bigger one. Okay. So then we're going to transpose it. T. So sum T, correct? Dot transpose. Like that. Okay. I think I get it now. So now 0, 2, it only takes 2 dimensions. That's what it is, right? It only takes 2 things. So now 0, 2. Right, so now I'm going to print both of these. So I'm going to print, we'll end with this, sum T, and I'm going to print transpose T. Okay, so I'm going to save it, run it. All right, so what did it do here? So this one, oh, let's do shapes instead. Oh, easier. Right? So this might be a little bit easier to visualize. What do you guys, how do you interpret this? So it was originally 3, 4 by 5, right? And I swapped what? I made the first one the last one, and I made the last one the first one. That's why it's 0, 2. Does this make sense? Let's do, so I think the thing is that was confusing is it only takes those 2 things, you know, the 2 dimensions that you want to swap. So in the 2 by 2, it doesn't, I mean, it, you know, right? I mean, I don't know if you guys see anything else with it. Here, it's 3 by 3, and we're swapping 2. Right, so let me try then the last thing. What would it be? 2 by 0, right? 2, 0. Kind of to follow that same logic. All right, I'm gonna save it. What happens now? Same thing, right? It did the exact same thing. So it kind of means it did still flip them. It just tells you what to flip them. Does that make sense? All right, so no homework today, but I do recommend go over all these problems. Check out this one, the transpose. Okay, definitely. As I said, once we start doing problems, you will usually just do the math part there and then double check that it did correctly what you wanted. It's always good. All right, but we can stop here for today, and I'll see you guys next Monday is Labor Day, right? So no class. So we will meet again in 2 weeks. Again, make sure that you practice all of this, okay? And this is we got to start here. All right, so if you have any questions, stay over and I'll happy to answer your questions. Have anything you want to. All right, otherwise, have a good rest of your week. Yeah, see you.